Hello, differential equation students. I miss you. I hope you're all doing well. Here is some review. If you haven't already checked out the test and you're looking for some extra review, if you've already taken care of the test, well, you don't need this. So, this warm-up, I wanted to do a warm-up like this because I haven't done any Cauchy-Euler equations higher than second order. So I wanted to make sure to give you some practice with that. So hopefully you recognize this is a Cauchy-Euler situation, right? With the powers that match the order of the derivative, right? So we've got your third power, third order, second power, second order, first power, first order, technically 0 power, 0 derivative. And this is non-homogeneous, right? So when I'm done with Cauchy-Euler, I'm going to have to go to any method to find the particular solution, which just doesn't look to be too bad, right? All right, so with Cauchy-Euler, we kind of know if it's second order, you can kind of skip some of that algebra that I did when I first taught this to you, basically saying you could just go right to the formula. But why I like the second method for this, it would be a little bit nasty to use the e to the x is equal to e to the t method when you're dealing with a third derivative. So I can do kind of the algebraic method, just like staying in x method, right, where we use, if this was second order, we would say, oh, a is 1, and the second coefficient is -8 minus 1, but that only works when it's second order. So I kind of have to go back to the proof, which was where you needed to have one less power here. So it's to do the homogeneous one, right, this is going to be equal to 0. We're going to have r times r minus 1 times r minus 2 minus 8. This is where the r times r minus 1. So remember when we did, when I went through the derivation of the Cauchy-Euler formula for this, where we were substituting, right, x to the r, this was the first derivative term. But now, because we've got a third derivative, we have to use more. So we have to go up 1 power. And of course, if I was dealing with the fourth derivative, I would start further back with r times r minus 1 times r minus 2 times r minus 3. Right? So this is just 28r minus 40. Right? That's how, again, there's another line in here with my x's, divide the x off, blah, 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 blah. And this is where, but this is all I really need to remember, because now you're going to distribute this out and you're going to get your r cubed, and I trust you can do this algebra, minus 3r squared plus 2r minus 8r squared plus 8r collect like terms. Remember, there's really y's along with this, right? There's really y prime with this, y double prime with this, y single prime with this, and then y 0 prime with this. And now I need to go into that right, factoring. So I either have to do factoring by grouping, which isn't going to work here, so I'm going to try, right, by synthetic division. If it looks like choosing, I always try something low, right? So 1's 1 minus 11. Nope, that's not going to work. Is a negative? No, negative 1's not going to work either, right? So maybe I'll try 2. 8, 4 minus 11. 2 is going to work. Right, so 2 is a 0, so I'm going to do synthetic division to get the others. So this is going to factor nicely, right? I don't need the quadratic formula. And then, of course, don't forget this one. So that allows us to say, right, that we have complementary remember our r's are exponents on x with our replacement with Cauchy, the second method of Cauchy-Euler. So I have x squared, x to the 4th, and x to the 5th. Now I have to go do the particular solution. And remember, the nice thing about this second method is that I didn't have to translate the right side, right? Because I was still dealing in x, so there's nothing left with, I'm still dealing here. So what I'm going to do, my particular solution, I'm going to say, well, that's just going to be some coefficient x to the negative 1. I'm going to do my derivatives. And then I'm going to substitute. Right, and I'm going to substitute back into here and get x cubed times y triple prime minus 8 x squared double prime and hopefully you see what happens here nicely. All the terms end up being an x to the negative 1. Right, because you have an x cubed times an x to the negative 4, an x squared times an x to the negative 3, and an x times an x to the negative 2. So, and remember I'm trying to match this coefficient here. So when I combine all these terms, I end up with negative 90 a x to the negative 1. That's a 1. So that's got to equal negative 9. Therefore, a is equal to 1 over 10, which means that my particular piece is right 1 over 10 x to the negative 1, or 1 over 10x. So I'm going to take that and combine it with my complementary solution to get my overall y. So this is my final answer. All right. So the only difference, again, I wanted to start and make sure that this piece was right okay for you to do when you're using Cauchy-Euler with higher than a second degree. I also wanted to show that I would get the same answer if I had done this problem with e to the t. Not from the beginning, because again, doing Cauchy-Euler with the substitution e to the t would be kind of gross. But I would have gotten down here, right? Because remember, when you do method 1 or method 2 of Cauchy-Euler, you get to the same complementary solution. And then you either have to turn, it's just a matter if you turn these into coefficients on your x's after you factor, right? I would have gotten these, I would have gotten this same factoring as well had I done the e to the t substitution. So I would have gotten, this just would have been gross, but I would have gotten down to here, I would have factored, I would have gotten these, but instead of making them powers, right, I would have made them e to the stuff, right? But then I would have put put it back in the end. So with that in mind, if I go ahead and erase all of this and put back my right, just work as if I'd already got the complementary solution. But remember, if you're going to use the substitution e to the t, you have to translate the right side when you go to solve for the particular, or put it back into x's before. But I just wanted to demonstrate that I could here, let's say I had done my substitution and I was going to find my particular solution, but with the particular solution I would have to translate this into, and remember the substitution would have been x is equal to e to the t, so this would just be negative 9 over e to the t, right, which would of course be negative 9 e to the negative t. So I would have done my particular solution, I would have said a e to the negative t, would have done my derivatives just like before. Which are kind of nice, right? But when I do my substitution piece here, I have to substitute not here with the x's. I need to substitute into the complementary piece, right? Which was, right, our r cubed minus 11r squared minus 38r minus 40, and realize which piece went with which derivative. So when I substitute in, I would have said, right, y triple prime, right, and that coefficient is 1, minus 11 y double prime minus 38 y prime, I'm sorry, minus 38, did I say 28? No, I'm trying to write 30, minus 38, and then minus 40 y, and that equals negative 9 e to the negative t. And look what happens when you do that. And the same thing, I'm trying to match this coefficient of negative 9. And when I do all of this, I have a whole bunch of a to the e to the a times e to the negative t's, and guess how many you had? That's right, negative 90. Negative 90a e to the negative t is equal to negative 9e to the negative t, so therefore negative 90a has to equal negative 9. A is also 1 over 10, but remember, that really goes back with this. So your y sub p is equal to 1 over 10 e to the t, right? Because that's e to the negative t, which is in the bottom. But what does that equal when you, now with doing this method, you have to sub back in for all your e to the t's, and you would get those exact same powers of x that we got with the other method of Cauchy-Euler. And of course, when you translate this back, transform, and remember the transformation we used was x is equal to e to the t, so this still ends up 1 over 10x, which is just what we had before, right? So again, everything would have been the same, and the only thing that would have been, the only reason to not do the e to the t method from the beginning with this one was this step, right? The fact that I had to, if you remember the proof of how we got the e to the t, just going to the third derivatives in this is just a little bit nastier. It's not devastating, but I definitely think that using the substitution x to the r is a little bit nicer with that. All right, so I just wanted to go through that with you. I would have done that on our review day. Then I would have had you pick up little book supplies, so I miss the fact that I get to see your little books, especially to know what, Hans, Charlie, and Andrew would draw, right? And we'd kind of compare it to Sam's, right? So our higher order differential equations, again, of course, you don't have to make this little book. But the first thing we did in this chapter was make sure you had the factoring and the long division skills necessary in order to do the homogeneous part, right? Where you have these equations set equal to 0. That's even, and if you are starting with a homogeneous, or even if you're starting with non-homogeneous, you have to do this first, right? And you need to be able to get your complementary. you need to be able to get y sub c, and then remember, you need to be able to deal with all the different, know how to deal with repeated factors. I wrote that over here, on this side. Don't forget about initial value problems as well. And whether that's, and I just put this on the homogeneous page, but I could have put it anywhere. Also, and then repeated roots and complex roots. Right, how you deal with those. You don't need to, we're not going to do that with the Cauchy-Euler, right? I gave that to you at the end of the Cauchy-Euler video of how to deal with repeated roots and complex roots, but you're not responsible for that. But you are for our regular higher order equations, how to make sure that you've got the linear independence and what you do with repeated roots and complex roots, okay? For non-homogeneous, right, higher order, it's just that second part. After you get the homogeneous, we will say you've got to know how to use undetermined coefficients, which I just kind of did, kind of easy problems like that in the warm-up. And then you definitely have to use the method of variation of parameters, or the MVP method as well, with the Wronskian and Wronskian using, right, the adaptation of Cramer's rule, where you have Wronskian 1 over Wronskian, and that's how you get your U's and da-da-da-da. Okay? Make sure you practice that. And the back was for you if you wanted to. Oh, no, sorry. Then Cauchy-Euler, method 1 and method 2, right? Remember, I called this where your substitution is x is equal to e to the t, and this one is, right, y is equal to x to the r, or the m, whatever. Y to the n, sorry. And then the back is for you. All right. So we would have done, we would have had 2 days of review, right, where we would have had you do that first warm-up, would have taken some time, and then we would have gone through the little book supplies, and then I would have given you the handout. Now, the handout you already have. I don't know if you remember, the Chapter 3 reviews had circled problems and square problems, and the square ones were to be for Chapter 4. I went ahead knowing that you may or may not have that or remember where it was. I've typed up the problems for you for Chapter 4's review, and I'll highlight that as soon as I'm done with this warm-up. But this warm-up was practicing initial value problem, and this warm-up would have been the second day. So I'm just going to go ahead and do that in this one. So if you want to pause the video and start this, see if you can do it on your own, or just watch me do it. So hopefully, again, you recognize the fact that you've got, right, second power, second order, first power, first order. So that this is a Cauchy-Euler problem, but it is second order, so we can just default back to our formula, right, where, whoops, our a sub 0 is 2, the coefficient of the squared second order, but that the next coefficient comes from, and this comes from the r times r minus 1, right? But we found out a shortcut to this is this coefficient minus the 2, which equals 1, and then of course the last coefficient is right? So my quadratic is 2r squared plus r minus 15 is equal to 0. Make sure I have my signs right. 6 minus 5, positive 1, yep. So therefore, what is r? And I'm going to use the, right, y to the power is equal to, I use, right, what did I just forget what I was going to say? You know what I mean. So therefore, my solution is, right, and I'm not going to write complementary because this is homogeneous. So just my solution is C1 x to the 5 halves plus my next constant c to the negative 3. I'm sorry, x to the negative 3. But this is an initial value problem. So, and this is why I put the, right, because I was going to do this example. That's why on your little book I put IVP, chose to put IVP under the homogeneous page, because I was going to do this example. So I've got the original and the first derivative. So I'll do the original first, which means that 0 is equal to 1, that's a 1, that's a 1, so is equal to C1 plus C2. Then I need the derivative. So the derivative of my solution and using that initial condition, 1, whoops, I forgot my C1, right? C1 goes in here and C2 goes in there. So when I put a 1 in for x, I get 5 halves C1 minus 3 C2. Now I'm going to solve a system here. You can either use substitution or linear combinations, matters not. I'm going to multiply this by this equation by negative 3. And copy it down here. That's a bracket, by the way. So what do I have? Negative 3. I lost my place. Negative 3 is equal to negative 3. Oh, sorry, I want to do a positive 3, don't I? Why am I an idiot? So this goes away. And what do I have? 6 halves and 5 halves. What is that? 11 halves. C1. Therefore, C1 is 2 over 11. Yes? And if C1 is 2 over 11, plug back into here. So what is C2? C2 is just negative 2/11, right? So finally, what does that allow me to do? It allows me to go here and say that my solution is 2/11 x to the 5/2 minus 2/11 x to the negative 3. Good. All right. So, and then we would have had chances, you would have seen if you had any questions on the review problems. And those review problems are here. So this is posted again. You do have these problems on a handout with boxes around them. I just typed them up on this paper. Oh, that should say chapter 4, shouldn't it? And I kind of dictated the method I wanted you to do. So hopefully you would realize to use Cauchy-Euler on this. Homogeneous, so just practicing your factoring, right? Your different factoring methods. That is going to take, I think, a factoring by grouping. We'll work with that. Maybe. I can't remember now. Yeah, that's what I did, a factoring by grouping. And then I wanted you to do this one with the undetermined coefficients, this one with undetermined coefficients. Here's another initial value problem. Again, I start off homogeneous, so it's not so bad. So you don't have to worry about the non-homogeneous part. Then this one, number 6, it's homogeneous and it's a 4th degree, so it's even higher. It's a 4th degree, but I gave you how it factors. Okay, so this was practice with some repeated roots. And then the last one I wanted you to do, kind of like I did that first warm-up, practice using the UC method. Oh no, that was with Cauchy-Euler, but still I want you to practice the method of variation of parameters. There wasn't really any forced practice with that. So I want to make sure you do that with number 7, okay? And then more practice with the UC method just to verify. All right. Well, I do miss you. I hope you found this helpful, and I will send an email out with our schedule, really our schedule here. The only thing you're responsible for this week is to watch this video if you need to. Some of you don't need to. You've already started on the test. The book assignment, chapter 4 book assignment is, I'm sorry, that shouldn't say book. Chapter 4 handout assignment. Again, I'm not going to check it, so don't do it if you don't need to. And then to finish the chapter 4 test by the 15th. Really, that's to give me time to grade. If you really need to the 16th, please go ahead. And then you have these check-in meetings if you want. If you just want to chat and say, hey, that's cool too, and or you have any questions. And then it won't be till whatever quarter 4 looks like, is going to look like grade-wise, don't know, but that's when we plan to start doing our last 2 chapters, 5 and 6. All right, I will talk to you soon. I hope you had a nice spring break.